Hello students, in this video lecture I am going to discuss solution of phase 1 question kinematics of motion in a straight line, question number 9. So let's just have a look here. An automobile start from rest and accelerates uniformly for 30 seconds to a speed of 72 kmph. It then moves with a uniform velocity and it is finally brought to rest in 50 meters with a constant retardation. If the total distance traveled is 950 meters, find the acceleration, retardation, and the total time. So as you can check it here, if we draw velocity versus time graph in this, because this is motion in a straight line, so we can have this. Automobile starts from rest. This side I am having V, velocity, this side I am having time, T. Starting from rest, okay, and accelerates for 30 seconds, 72 kmph. So you can convert 72 kmph to meter per second. So you will get here 20 meter per second. So it will become like this. This is 20 meter per, and this value is how much? This is 30 seconds. Correct? Again, after this, it's a start traveling with constant speed. Okay, with the from velocity. Okay, all right. And after that, it's brought to rest in 50 meter with a constant retardation velocity. Okay. All right. So see from here, O, A, B, C. So AB distance it's traveling with constant velocity, right? And OA distance it's traveling with acceleration, and BC distance is traveling with retardation, right? And okay. And total distance that means area, right? Area of OA BC is equal to 950 meter, correct? All right. And this BC distance, this distance, let's call this D, right? So this area is equal to how much? 50 meter, because area of velocity versus time graph will give you distance traveled here, right? So now you can say it here. So this is 50, and for this, let's call this E. Distance OAE is travel. This velocity became how much? This is 20, and this is 30 seconds, right? So I can say distance OAE is equal to half into 20 into 30, right? And that should become equal to half AT square, right? Because it's moving with constant, with a zero initial velocity, right? With constant acceleration. So I wrote here half AT square. So this cancel. Okay, and T is what? 30. So 20 into 30 is equal to A into 30 square. So A became here, yeah, 2/3 meter per second square. This is the value of A that we got. Okay, so acceleration is how much? 30 meter per second. And this distance is how much? This distance, distance is how much? Half into 20 into 30. So 300. So distance OAE, right? This area became 300 meter, right? So this is 300, and this area is what? 50. So this area AEBD became how much? It's a 300 plus 50. This is 950 minus 350. So this became 600 meter, right? 600 meter, right? And it's moving with distance AB is moving with constant velocity 20. So let's say time spent in this distance traveling is T2. So I get 20 into T2 is equal to 600. So T2 will become 600 by 20. So this became 30. So 30 second. Correct. Now, after traveling distance AB, starts retarding, right? Okay, with constant acceleration. Now here velocity is how much? Velocity is v, and this 20 meter per second initial velocity, and this distance is 50 meter. So I can apply formula for BDC, right? BCD, right? V square is equal to U square minus 2A S. V is 0, U is 20 square minus 2A, and S is 50 meter. So once you simplify this, you will get here A is equal to 400 divided by 100. So 4 meter per second square. So here we got retardation is equal to how much? 4 meter per second square. And let's say time spent in this journey is T3. So how will you find T3? T3 is equal to U by A. U by A. And U was 20 by 4. So 5 seconds. So total time taken is how much? 30 seconds. It's spending time in moving with constant velocity. Before that, you travel first 30 seconds. So 30 plus 30 and here 5. So total time is equal to 30 plus 5. So 65 seconds. Okay. So this is the solution of this question. Okay. Thank you.